What are we here to talk about? We can just go ahead and jump right on into it. So Kelly and I have spent the better part of the last 6 to 9 months working on a very new, very confounding, and super surprising problem in the enterprise fintech space. So I'm referring specifically to digital check fraud. What we'll do today is share with you what we've learned about that problem as we've engaged in building a solution to it, as I mentioned. Some of the things that we'll share with you are things that we've learned about the applicability of machine learning, computer vision in that domain. We're also going to share with you the fact that computer vision, machine learning, data, those are not enough to solve this problem. Why? They're not enough because we need actively engaged human expert collaborators in order to work right alongside our mathematics, our ML, and all of our data to make this whole thing work. The problem is too large its scope in order to solve it otherwise. So how do we do that? How do we do that? And what will our agenda be today? How are we going to tell that story to all of you? Well, so we'll start by unraveling the problem of digital check fraud. I want to make certain that I impress upon you the criticality of this issue, the scale of it, and just the fact that it's a very, very difficult thing to kind of unravel. We'll talk with you about data science, about machine learning, about how those tools and those techniques play a major role in our eventual solution. As I mentioned, we need human collaborators in this endeavor as well. Kelly is going to be here to share with us some thoughts about how do we do that. And then finally, we'll talk about network effects and how we are very, very eager to leverage broad-scale network effects across the networks that we build so that we're able to cast out our solution across a maximal population of end users. So, as I mentioned, we're talking about check fraud today, and if you're like me, coming into this first blush, you need a little bit of a refresher, beginning with what is a check? Briefly, checks are really easy to describe. So they're these special pieces of paper that your bank prints out for you in a stack, and then they mail that stack to you. And then whenever you need to pay someone or exchange value with another human, you write some letters and numbers on the paper, give it to them, they send it to their bank sends it back to your bank, and at the end of all of that, a transaction has been complete. Also, if you're like me, you have another question, and that is, that's a check. Do people use those? And the answer is a resounding yes. Pop quiz. What's the most common form of business-to-business payment in the United States? Oh, yeah. It's checks. It's it's wires. Wrong answer. It's checks. Didn't mean to pick on you. Sorry there. Okay. A very widespread usage. It's also used in the business-to-consumer space. When Amazon has to refund you something, they will send you a check in the mail. So massive, widespread uses of checks, surprisingly enough. Exacerbated by new technologies. Your ability to kind of get out your smartphone, take a picture of a check, and then you're done with the dead tree version of that transaction that exists in the digital world. It's very convenient. And along with that convenience comes widespread usage. But along with that widespread usage comes another thing, comes fraud. Why? Fraudsters are opportunists. Anytime you see a disruption to a legacy system like this mess of thing that you see on your screen right here, well, that's an opportunity. It's an opportunity for bad actors, so they're very, very much here. How big is the problem? It's gigantic. 60% of all attempted fraud against deposit accounts, you guessed it, check fraud. 47% of FI's total losses across all fraud types comes from check fraud. As I mentioned, this is a very timely problem. It doubled in 2021 due to a whole bunch of things. The pandemic, disruptive technology, your ability to take out your smartphone and kind of take this check and enter it, usher it into the digital world in a very convenient manner. What does check fraud look like? I can tell you, I saw a movie one time where this dude would dress up as an airline pilot and fly around from city to city, and he would cash bad checks before anyone was the wiser. The movie was, I don't know, that was about like what check fraud looked like in the 50s and the 60s. I don't know, it's been around a long time. I can tell you it looks vastly different today. Doesn't look anything like that at all. So what we see are super sophisticated and very well coordinated attacks that span multiple channels, multiple different networks, TikTok, Roblox, Facebook, email campaigns. What we see are fraudsters, bad actors targeting young people, first-time account holders, preying upon financial vulnerability, financial naivety, and just a bad overall kind of situation to find ourselves in. What does it look like? What does fraud look like? Check fraud comes in a whole bunch of different shapes and sizes. I'll share with you kind of a typical anecdote around what happens. So you'll see a mass email get sent out to a whole bunch of people, and it will say something along the following lines: "Dear sir or ma'am, I represent company X, and we require your assistance in this financial matter. If you take this $2,000 check that I'm just going to give you and deposit it into your account, take a picture of it, and then after you have that deposited into your account, wire $1,800 to this other downstream account. In exchange for your services in this financial matter, you get to keep that extra $200. Right? So invariably, almost no one falls for it, but always people do. It's kind of a numbers game in here. What happens when they do? Just really, really bad experiences. Their accounts become overdrawn, they're back to the payday loan vendor, their business suffers, all kinds of negative outcomes. There are even worse stories. There are stories that we hear from the field, from our customers, about people who go engage in honest work over the internet for a week, 2 weeks, weeks at a time, right? And at the end of that, they're expecting to get paid, they get a check, and instead of getting paid, they're getting robbed, right? Just bad, bad, bad. So, as I've described, there is a ton of just really rich contextual data and information that surrounds a successfully executed fraud attack on the check side. How did we learn about all that? How did we learn about that rich context? How do we learn about all the things that are going on around the checks themselves? Well, we did so by doing things the only way I know how to do them. Like if there's a problem, you got to go to wherever the problem is, and we did that. We went out to where the problem is. Now, where is that? The problem is in financial institutions across the country of all different shapes and sizes. They all have fraud teams. Those fraud teams work in complete isolation from one another, and they work in all different geographies, all different markets across the country, across the globe, and they all see different things, when it comes to check fraud. Different patterns, kind of different, just slightly different perturbations of, for instance, some common themes. Right? But they're all different. Now, if you step back and you view that space collectively, well, they see everything. They see everything. So what did we learn? What did we really learn when we sat down and started, talking with the people who have this problem? A couple of things that we learned were, like, we could have guessed them, right? Check fraud shares many common characteristics with other fraud types. Anomalies around application access behavior. We're all creatures of habit. We tend to interact and access systems consistently over time. Patterns emerge. We're able to leverage data and machine learning to kind of observe those patterns and detect deviations from them. Transactional anomalies. There are a lot of those. None of this is new to us. We'd seen it many, many times before in other transaction types. But over the course of this process, we begin to hear curious statements from these analysts and these fraud teams that we work with so closely. Statements like, oh, and by the way, this check, it was taken off of a computer screen. That doesn't really happen a lot with normal end users, but it happens a lot with fraud. This is an example of that. Strange fonts. I'll never forget the way that this particular signature was characterized to us by multiple different teams who weren't communicating with each other. They said things like, yeah, what we see are these curious kind of stacking of characters and fonts, things that we don't typically see in legitimate usage. Particular signatures, handwritten signatures. To all of us in here, this probably just appears to be just a random kind of scroll of ink on a page, but it's anything but that. There are a very particular set of signatures that seem to correlate really strongly with fraud across distinct institutions, distinct attacks. And then finally, other interesting comments we began to receive were, hey, look, this check, it was photoshopped. Different fonts were manipulated and added, fields were pulled in and dropped. If you look at the fields, the various fields that are represented in this check, it's curious. The fonts don't match up. It's been manipulated in Photoshop or Microsoft Paint. So we hear a bunch of comments just like this. And again, what do we do about that? So the thing that we do is, well, we build a network. We build a network that connects all of these disparate and unrelated, heretofore, experts. That network makes it trivial for them to share back with us their deep and hard-earned insights, insights that Kelly and I can't produce. I've looked at hundreds of fraudulent checks, and I can't identify them to the degree of accuracy that human experts do. So what do we do with this network? We operate at the nexus of it, all this information, all this collaboration. We take all those insights and we train ensembles of computer vision-based transformers, transformer-based computer vision classifiers, and semantic segmentation models, so on and so forth, such that together, collectively, those ensembles represent the entirety of the knowledge base that's kind of spread out across that, that disparate set of experts. We're operating here at the intersection of a whole bunch of kind of classical ML that we do around the more tabular kind of components of the data, stuff that you can imagine, dates, amounts, this kind of thing. We're operating at, again, the intersection of this classical ML, computer vision-based techniques that are all kind of, based upon the broad-scale insights that, that members of our network share with us. And then finally, that third piece, that third critical piece, engaged human expert collaborators. But they don't come willingly. How do we engage? How do we get them? How do we get them on our side? How do we get them using our great product that we spent all this time building? Kelly's here to share with us the finer points around that process.
All right, thank you, Jesse. So for step 3 of this process, we've gone into a deep dive into the different machine learning algorithms, the AI, the technology that enables all of this. But the technology is just sitting there in the computer. It can't actually solve the problem of check fraud by itself. And that's where machine insights then meets human expertise. So we talked about the research that we had done with financial institutions, talking to different users, different employees of the bank. And what we found from all of that research is that a key problem across all the financial institutions, no matter the size, no matter their geolocation, is that they're all dealing with these knowledge gaps. All of these different people who are extremely smart and know what their business is, or for a personal banker, they know their customers. Fraud specialist knows the signs of fraud, knows how to do research on fraud in order to look into the history of that transaction or that account. But they're all working in these completely unconnected software systems, and their knowledge is sitting in their heads by themselves. The software that they're using is disconnected. The data is stored in different places, and it doesn't talk to each other. So how do we solve this part, this human part of the problem, of how humans work with the technology? Well, these people already have communication patterns in place. People are really good at talking to each other. That's what I'm doing to you right now to communicate information. And then what we did here in a redesign of the suspect transaction report is just to get that information, those insights from the AI, into a form, into a user interface where the fraud specialist can actually take a look at that and communicate it effectively in the fastest way possible to their partners, the account holders and the regional bankers. In order to do this, explainable AI needs an explainable interface. What I'm doing here is trying to open up the black box of machine learning. We're not just going to present a whole bunch of big data, but how do we present it in the most effective way so that me, the fraud specialist, can then take that information in quickly and communicate it out quickly? Because we know that check fraud is at a high volume, high speed, and this is just the speed of the problem we need to solve. So this UI transformation tries to do that using both cognitive science and UX, UI, and visual design principles. Here's the legacy report that we started with. So this RFA report, just looking at it visually, it doesn't look as slick. But the problems that it actually has is that it provides way too much information of the type that our users actually did not understand. We're not just talking about mean, median, mode, but we were using words like skew and kurtosis. And fraud specialists, they know a lot about fraud. They don't know a lot of statistical terminology. It also didn't provide enough information in the areas that they wanted to know. So you're looking at this map of the US here, right? It's at a regional level. So, just casually, the entire west of the US is where this login or this fraud might be coming from. So you know exactly where that is, right? No, they actually wanted geolocation data at the level of the specific IP address so they could pinpoint where those logins are coming from. And those are some of the types of information the redesigned report provides. But along with providing ML-based insights and a lot more data than before, this is actually too much information for them to take in at scale. So a lot of cognitive science principles and UX principles were applied in order to make that more palatable. Cognitive science. Why is psychology important here? I think we heard from other people how data science, it's just one part of the team. But in order to get people to use it and understand the complexities of data science, we have to also understand the psychology of how human brains work. We have a lot of unique abilities as humans, but also limitations that machines don't necessarily work around. One of those, for example, is cognitive load and working memory. Now, a database can store as much information as you want to put into it. But we can actually only store 3 to 7 discrete units of information at a time. That's our cognitive load or working memory. So if we are presenting tons and tons of big data, which is kind of inherently what machine learning operates on, that's too much. Instead, by simplifying and organizing the design, then this allows people to identify complex information and understand it more easily. So how this works in the suspect report redesign is that we present high-level information first in a summary, and then you click in per each factor of the machine learning report to understand the detailed cluster or date range data. Sorry for the font mess up here. Another element of cognitive science is preattentive processing. And you'll start noticing that these cog-sci and UX principles are really just layering on each other. So similarly to the last one, in preattentive processing, we're actually able to take in a lot more information as a whole than we can consciously understand. So I'm listening to all of the background noise, I'm looking at all of your faces, but I can't memorize every single face, right? This is where drawing attention to one thing at a time through things like color, form, spatial positioning, and movement can be used in order to draw people's attention to that most important thing. And this consistency also helps users quickly identify when there's new information or a change in information. So in a suspect transaction report, I place the same suspect or normal or safe statement in the same position every time, that positioning. And then the color and the icon also helps indicate if something is different, whether that's safe or suspect. Multimodal communication. So I think a lot of people have heard about things like being a visual learner versus an auditory learner. This is kind of the same thing, and it actually has to do with the individual differences in our brains as well. Because those of us who are very visually focused might have more neurons, more connections in our visual cortex. Those of us who are very language focused might have more developed language cortexes. So when we present information in multiple forms, whether that be graphical, textual, audio, or even interactive, this really helps people take in information in the way that best works for their brains. And when we also add things like proximity and synchrony, then that reinforces the message as well. So in this example, in the summary, because the fraud specialist is trying to get on the phone with an account holder really quick, and they might just want a single sentence to read out with them, we provide that decision summary in a textual form, but also if they're in research mode, if they're not on the phone, some urgent situation with someone, and they're trying to deeply understand what factors caused the decision to come back suspect, I wanted to show a visualization so they can see the sequence of events and the relationships of the factors to each other. Okay, now moving into UX and UI design principles. So Gestalt, weird word, probably a lot of you haven't heard of it before, but all that it means is the way that we create an organized whole from different parts. So what do you see on the screen right here? Anybody? Yes, it's a dog, but what do you actually see? It's just a bunch of black dots on a white background. There's no actual dog here. That's how Gestalt works. there's a lot of these detailed visual design principles, whether it's proximity, symmetry, continuity, that allow our brains to read into that. And even though that E, it does not actually have a top and bottom line, the principle of closure allows us to interpret it as an E. The S is actually being blocked in the middle by that yellow line. But actually, we are just interpreting it like the S curved around the line. Our brains can fill in so much information. Gestalt, using these different parts to create a whole, is at work on a velocity page here, where I have a header, so that area of information talks about the transaction as a whole. Then this middle section is a summary of what's going on, of current and past velocity. And then as you go further down the page, there's a whole created from the velocity history. Hierarchy is also at work to draw your attention to the most important information on the page. Hierarchy is the process of arranging elements to show their order of importance, and it can use multiple techniques. In this example, when the diver and the whale are about equal in size, then it actually creates a nice harmony, but it doesn't draw your attention to one of them first, which the second one does when the whale is huge. Besides scale, you can also use contrast, direction, and position to create visual hierarchy. And it's at work in the suspect transaction report by using positioning to put the current or login information first, and then using color and the large size of the map to draw your attention to that as the primary mode of interacting with the table on the right. In progressive disclosure, this is a UX principle that makes applications easier to use by showing a little bit of information first and putting the control in the hands of the user to go in deeper and show more advanced or rarely used features later on in the application. So you can kind of think of this as just taking away the irrelevant info at first and then instead showing it later on. Or you can think of it as going from a small to a medium to a large amount of information, so long as you give that control to the user to show the right information at the right time. In a login report, login can go over thousands, hundreds of thousands even of events. But what we're doing is comparing the current login, which is always at the top, to these different clusters of logins that might have taken place all over the world. We put the control in the hands of the user by allowing them to click into a cluster, which opens up that cluster's login events in the table on the right. And then going a level deeper than that, if you wanted to know more information, like the specific IP address, as I was mentioning before, of an event, then you click into that row of the table, open it up as a tree, and then you can get as deep into the information as you choose to. So, in summary, great UX is needed to enable human-AI collaboration. If I were trying to do my job with the older legacy report, I can only get so far. And this is why working as a team works great in order to better solve this check fraud problem. What I've talked about so far is pretty much unidirectional, though. You know, we've improved the ML algorithms, we've redesigned the report in order to better communicate the insight from the machine to the user. But what about working as a system? What about making it bidirectional? How do we scale the power of the system? So at this point, this is where a fraud feedback loop comes in. This is our next step. Now, we already have this process called case decisioning in the legacy system. And the next step of the redesign would be to allow the fraud specialist to take in those insights that only those regional bankers or the account holders know, working together, collaborating with them, and putting that information back into the machine so that we start to create a true fraud database. And then that database can be used to improve the suspect transaction report. It's a really positive flywheel that feeds on itself. Going even further beyond that, how do we create a network of fraud feedback? Well, Q2 works with multiple financial institutions. Each of these teams are working together within their siloed departments, becoming less siloed, and then feeding it into a central network, so that as we take a step back and look at what's going on as a whole across this network, I'm going to stop for a second and ask a little bit of a philosophical question. Where does intelligence live? It's in my head. It's in each of your heads. intelligence, specialized knowledge exists in the fraud specialist or the regional bankers' heads. But it also exists at a higher level with team intelligence. There are things that a team can do, an organization can do, that individuals cannot accomplish. And then we're all here today to talk about artificial intelligence, the intelligence that lives inside the machine. And as we start to link all of these different forms of intelligence together, we start to create a type of systems intelligence that is greater than the sum of any of its parts. I was talking about Gestalt earlier. As we step back, look at this fractal illustration, we kind of can start to see a type of intelligence that emerges and is not embodied in any one of its individual parts. And this is the end goal that we're really trying to get to, so that we can bring all of this intelligence to bear against that problem of check fraud. Thank you.
Okay, guys, we have time for one question, so make it a good one.
No pressure.
Thank you so much. Thank you so much, Kelly, Jesse. Really appreciate it. I did have a question about when creating that UI, did you just ask the users for feedback, or was it A/B testing of sorts? Because your users potentially can be external as well, right?
Yeah, we did two forms of research called generative versus evaluative. So at the beginning, we did interviews and product demos with people in order to identify the problems. And then once I had a first iteration, which I actually didn't show today, of the suspect transaction report, we had them perform tasks, cognitive tasks, using that report. You can take metrics using a survey for levels of usability and attractiveness or time on task, for example, and then also just interviewed them after they used the redesign report to get more feedback.
Thank you so much. Yes.
Just to add one note to that. We live with our end users. That's where we discovered the problem. That's where we discovered kind of the finer points around it. And as Kelly just mentioned, we work with them very iteratively, very interactively to figure out how to build an amazing product for them.